Hey guys, welcome to Code Decode. This is the second part of our microservices interview questions. So let's get started and see what we are going to cover. We are going to cover the very first thing today is microservice architecture. What are the features of microservices architecture? How do these microservices communicate with each other? What are the different ways in which they can communicate with each other and with which business logic you should use which one? What is the difference between the monolithic one, the SOA and the microservice architecture, and how to design a microservice architecture, and so on, what all things we have left in the previous one. So let's get started with the architecture first. Now a very important thing in microservice architecture is that there is a client. So in our terms, there were some citizens who were trying to register themselves to the site. So there will be something for sure in between which is known as the Spring security in the terms of Java, or something else in terms of Node.js and everything. So there will be some kind of security and identity management like Okta will be implemented for sure between the client and your microservices. So that will, the choice of is completely yours. Either you want to implement the security in each of them, duplicating it, or on API gateway. The preferred one is always implement these kind of things in API gateway. So what is API gateway? I have already covered in depth about what is API gateway and how to implement this using Spring Cloud in Java in a tutorial format in the playlist given in the description below. So this is the API gateway which acts as an entry point for each and every individual trying to access your application, and from API gateway we have routing mechanism which routes each and every of your request depending on its nature to which of the microservice it wants to redirect to. Then you have your microservices, like for example this is our citizen microservice, this is our vaccination center microservice. And then there is a service discovery. We have used Eureka from Netflix OSS in this particular scenario. So all these microservices and API gateway are the clients to the service discovery Eureka. And this is basically a server which acts as a registry and holds each and every address of each and every microservice. So why was it needed? We have already covered that. Just for the revision purpose, let's see. So suppose these were three microservices who were interacting with each other. Now if I want to get some data from microservice 2 and microservice 2 wants to get data from microservice 3, it has to use suppose like REST APIs to interact with each other. So both uses REST to communicate with each other. Now one is working on 8081, second 8082, third on 8083. So if you deploy these microservices on cloud, these port numbers are not constant. These are variable. So whenever you change your instance in your IP address, everything changes in cloud. So what happens is, if this is dynamic in nature, you cannot hard code this port number and URLs in any of these microservices. So how will microservice 1 know about microservice 2 and how would microservice 2 knows about microservice 3? There is no way to do that because the port numbers on which these instances are running on cloud is completely dynamic in nature. So to prevent that particular scenario that you are not able to discover this particular microservice, there is discovery service. And here in case it is Eureka for us. So it is a registry. It says, okay, currently my microservice 1 is working on 8081, microservice 2 is working on 8082 and 3 is working on 8083 and so on. As soon as your instance gets changed with the new IP address and port number, this particular registry crosses this particular one and updates it to 808485 whatsoever new port number it has got or the new IP address it has got. And hence whenever this particular microservice wants to go to microservice 3, it asks Eureka, where is microservice 3? It says okay, it was on 8083 but the updated one is 8084, so I'll give you an address of 8084 and there you can find microservice 3. So that is why Eureka was that important in our architecture. So whenever it comes to microservices, the very important part is the discovery service which helps you to discover microservice so that you don't have to hard code its URL and port numbers in the application itself. The second important part was API gateway. We have covered why was it important. It actually does many kind of functionality that you don't have to implement the security and everything here. You can do everything at this one platform. It is an entry point because your front end should not know which URL, which port number your microservice is working. It should just know one application which interacts with, and the task of API gateway is to route based upon your requirement. So this is the architecture and how it used to work. We have already covered these important things in the tutorial. Link for the playlist is given in the description below. Now, what is the main feature of microservices? So there are multiple features because of which microservice got so famous in the market today. The first very important one is that it breaks the application into smaller services. Because of this, it is possible to deploy and develop each of these services independently, and hence new feature introduction becomes very much easier. So there can be a case that one of my application, citizen service, is working on Java 8, but my team working on vaccination center is much more fast forward. It wants to do much more enhancements, and it just moved to Java 11, and still both are interacting with each other comfortably. So that is why introduction to new features is very much easier. Second point is decentralization is involved in microservice architecture. So what does that mean? So it means that your data management is decentralized. There can be a monolithic database which is common to all the service, or there can be one database for each microservice depending upon your business. But the point is each service has an ownership of data related to business functionality of that service. So every microservice is going to fetch only the required data from database, and rest is removed. So that is why decentralization is what is introduced with microservice, and hence the loose coupling. The third very important feature is black box. What does that mean? It means that my vaccination center does not need to worry about any of the citizen service business logics or any of those things. It is completely black box. The citizen service is completely black boxed to vaccination center. What does that mean? My vaccination center does not know anything about citizen service, what technology it is using, whether it is using Java. So I am on Java. Is citizen service also on Java? It doesn't need to know. It does not want to know. It does not need to know, because it can be on any of the technologies it wants to, and hence the complexity is hidden from the other services and components, and hence it is black box in nature. The fourth important feature of microservice is security. Now, microservice platform itself provides some capability for certificate management, different types of credential, authentication, authorization, authentication based on role-based access models, and everything is provided by microservice architecture. But a very important feature here is security is decoupled from microservice development team, as it is platform standardization. So the task of implementing security is now given to API gateway. You can implement the security on this level, and your developers need not worry about the security at all. The person developing and handling the API gateways and the platform will be capable enough to do that for you. So that is why even the team working for the different microservices need not worry about security. The very important feature of microservices polyglot we have already covered in the first part. The significance of this microservice architecture is that it is polyglot in nature. What does that mean? If you have 5 people working in Java, you need 10 people to complete your application and deliver to client in 1 month, then you don't worry about just 5 people working on Java. You can also get like 5 people working on Python, Node.js, give a separate service, make them work together, and then you are good to go and to deliver the application to client. So this is polyglot in nature. Different microservice can work upon different versions, like it can work upon Python 2.7 or 3.0, it can work upon Java 8, Java 11. Different programming language can also be used, one on Java, one on Python. Different architecture can also be used. So one can be monolithic, one can be microservice, but still they can interact with each other. Now a very important question, how does microservice communicate with each other? So this is a very important part you should understand. So let me first make you understand how it works, and then we will go to the theory part. So in our example, we had a vaccination center, we had a citizen service microservice. Now a person logs in to a UI, it gives you its mobile number 9 something something something, it gives you the OTP, and this is the process of security that I have shown you in the architecture. So here the security in Coven site was when you give your mobile number, you give the OTP to site and it authenticates. This is the valid user. This is the kind of security they have implemented in Coven. Now you give a request to vaccination center after security is successful. When you get into the application, you want to know that at this particular vaccination center, how many citizens are already registered. So you need the details of vaccination center, address, name, and also the citizens who are registered to it. Now, this is one transaction where you make a request one to vaccination center. Vaccination center makes a request to with REST API to citizen service. It responds you back and then you get a response back. But in the meantime, as the design or the architect of this application, I want to log each and every request coming to my system so that if something fails, I should be able to trace it. So there is one service I have created separately for logging purpose. So being a user, I want a quick response. So this is the REST API that I have implemented. But as the designer, it's okay if there are too many kinds of requests going on. It's okay to have a delayed logging feature. So what I can do is I can make it synchronous, that once only and only when the vaccination center gets response from citizen, then only give response back to client. Client doesn't want that. If I am asked you, give me the detail of vaccination center and citizens registered to that vaccination center, just don't come back to me saying this is the vaccination center detail, this is vaccination center name and address. I cannot give you citizen service because this is not synchronous. I don't get a response right now. I cannot give that response to you right now. So this is not an eligible response given to a UI or given to a user. What it needs is give the response collective only. So what is expected here is that this should be synchronous. Only when you get a response from citizen service, return it back to this UI. So this is a synchronous nature. But is it really important that when the citizen service responds, then only log your data to logging service? No, it's not important. The logging should not wait till your response comes from citizen service. So this can be asynchronous. It doesn't depend upon response from another microservice. That is why what you can implement here is RabbitMQs, ActiveMQs, Kafkas, so that you can just put your message of logging into this queue as the message 1, message 2, message 3. When the logging service is done with message 1, it will pick your message 2 from queue and it will log into its logger. So this is asynchronous nature and this is synchronous nature. Waiting for the response and again giving back response to UI is a synchronous one. But you are not waiting for response and you are logging and you are putting message onto the queue and forget about it. Logger service will automatically pull your data from the queue, log it into its logger, and it doesn't want your response back. Till then, when you get back and saying that I'm done, all the 3 messages are logged into your logger, by that time your user have been taken its response long back. So that is asynchronous nature. So now let's get back to the theory. There are 2 types of inter-service communication we have seen, synchronous and asynchronous. In case of synchronous communication, client waits for the response within a time limit. The possible solution is using HTTP protocol via REST API for inter-service communication. We have seen this, we have implemented all these applications using synchronous nature REST API. The second one is asynchronous communication. In case of asynchronous communication, client doesn't wait for response from another service. What it does is when the client microservice call another microservice, the thread is not blocked till a response comes to server. The message producer service generates a message and sends it to the broker on a defined topic. Too much theory? So this is called, the queue that I've created is called a topic. This is a message producer. It produces a message, put it on a queue or the topic, and then message producer waits for only the acknowledgement for broker to know message is received by the broker. So only the time till this broker or the topic says yes, I have received your message, till then it waits and then again it starts publishing another message to the broker. So it keeps on producing message on the broker until it has been done with its work, and it waits only for the response from broker and not from the logging service. The consuming service, here in our case it's logging service, is the consumer service. Subscribe to this topic in the queue. All the message belonging to the topic will be fed to the consuming system. So all the message which comes here is given one by one to this service to log. The message producer service and consumer service doesn't even know about each other. So logging service doesn't know about vaccination center doesn't know about logging service. They interact with something called as intermediate one, which is the broker or the topic in our case. The response is received in the same methodology through the message broker via defined message topic. So the same thing happens. It gives there must be some consumer here. It gets the message, logs it, and sends response. Okay, I got it. Give me the next one. It logs it. Give me the next one. So this is completely asynchronous in nature. They doesn't communicate directly with each other like vaccination and citizen service in our case. So what are the tools out there in market for this type of asynchronous communication? The tools are Apache Kafka, RabbitMQs, ActiveMQs, and these are based upon advanced message queuing protocol system. The video on tutorial on this topic is not yet created. If you want to have a look at how ActiveMQs and RabbitMQs work, how Kafka work, the detailed demonstration with Java based application, if you want that, just let me know in the comment section. I'll create that one for you. Now, what is the difference between monolithic architecture, service oriented architecture, and microservice architecture? A very important question from interview perspective. So now I'll give you an example first, and then we will go into the depth of this. So I go to an interview asks you, how did you implement your microservice? I say, I have one vaccination center, I have one citizen service center, and they both interact with each other through REST API, and that is my microservice architecture. Then and there your interview will reject you. Why? Because what you have answered is that you have one application, you have another application, they are interacting with REST API. This is not microservice architecture. This is service oriented architecture. So you should for sure clearly know the difference between what is monolithic architecture, what is service oriented based architecture, and what is microservice architecture. Now I'll give you an example. Suppose I had a citizen service and a vaccination service. They are working on their own. Now there is one Google API. This API takes longitude and latitude, and country city pin is what it returns you back with the directions also in map. So it takes input as this and gives output as this. Now my user, while registering, I ask the person, where do you live? Now suppose I get the longitude latitude from the map and give it to Google API, it returns me with this country, city, pin, everything of that user. So this is an automation. I don't want user to fill a big form which says what is your name, what is your country, what is your city, what is your pin. You don't need to do that. Just mark where you live in your map and I will fetch all this thing. Similarly, while registering a vaccination center to a database, say I want to register this particular school as a vaccination center, then also you just have to give the name and the location. I will fetch latitude, longitude, and I will give all these data, where, in which country, which city, what is the pin of that vaccination center. So these two have a common feature, that is they want these data in their application. Then they both give a call to this API. It gives the directions in map. It gets all the information about that particular location. So this is the service oriented architecture. This is reusing. This is sharing of data. They don't want to implement this API calls independently in their application, and hence they created another API which gives a call to this API. They are just reusing or sharing this data amongst each other. So this is service oriented architecture. But what is microservice architecture? Creating those services separately, creating microservice citizen, microservice vaccination center who doesn't share any kind of data with each other. They are completely independent. They don't share anything. There is no reusability of code. Even though it has some piece of code, it also has some piece of code, but they are not sharing with each other. This is microservice architecture. So very important difference between service oriented architecture and microservice architecture is the reusability of data, and sharing of data is a complete no in microservice and is always agreed upon in service oriented architecture. So let's get into the details of it now. The one monolithic, we have already covered it many times. It is similar to a big container where all your components live and assemble together and completely tightly packed, and hence very high coupling and low cohesion, which is a very bad practice. Nowadays, most of the people with a complex architecture are now moving from monolithic one to microservice one. Service oriented architecture is a collection of services which communicate with each other and they involve simple data passing or could involve two or more services coordinating with each other. Too much of theory, I've already made you understand what is service oriented architecture. Collection of service which communicate with each other for a common data, sharing of data, reusing of same kind of data, that is service oriented architecture. In terms of microservice architecture, it is a collection of small autonomous services modeled around a business domain. So my business domain says there's a citizen, there should be a vaccination center, then they are completely decoupled, there is a loose coupling, high cohesion, and a very good design practice. So the main difference between microservice architecture and SOA is the sharing of data and information is the main difference. SOA shares and reuses as much as possible, while in microservice we focus on sharing as little as possible. Now we have many more things to cover, but we will be covering these part in the next video. We are also putting a like ratio of 300. If we cross this 300 like target, we will be creating more such content on how to design a microservice, which database to use, what are the design patterns which we use, how to secure it, how to deploy on AWS, Docker and everything. So let's meet in the third part. Thank you.